Measures of central tendency. We're first going to look at the mean, which is also the same as the average. The mean, or average, is the sum of the quantities in the data set divided by the number of quantities. The formula for the mean is x bar equals the sum of x sub I, all divided by n, where x bar is the mean. This Greek letter sigma means the sum, or the sum of. X sub I represents each x value in your data set, and n is the number of values in the data set. For example, we have 5 pulse rates. The pulse rates are 68, 84, 76, 72, and 80. Using the formula for mean, we are going to replace the numerator, the sum of x sub I, with all our pulse rates, adding each together, 68 plus 84 plus 76 plus 72 plus 80, and then divide by the denominator, n, which is how many are there? There's 1, 2, 3, 4, 5. So we're going to divide by 5. When we add our numerator together, we get 380 divided by 5 gives us a mean pulse rate of 76. Another measure of central tendency is the median. The median is the middle value when the data values are arranged in order from smallest to largest, or from largest to smallest. For example, in the numbers 72, 88, 76, 64, and 68, to find the mean, we must first place these in order from smallest to largest, or largest to smallest. I am going to place them in order from smallest to largest. So the 64 comes first, then the 68, then the 72, then the 76, and then finally the 88. Now I find the middle value, which is 72. So the median for this set of data is 72. Another example of median, here we have an even set of numbers, 1, 2, 3, 4 values. So there is no middle number. So to find the median, we add the 2 middle values when you have an even set of data values. We add them together, 56 plus 62, and then divide by 2. So we're finding the mean, or the average, of those 2 values. 56 plus 62 is 118, and divided by 2 gives us 59. So the median in this example is 59. On the last example, we had an odd set of values that you simply pick the middle number. When you have an even set of values, you must add the 2 middle numbers, divide by 2. Another example of measures of central tendency is the mode. The mode is the value that occurs most often. So looking at this example of hourly pay rates, we see there are 2 at $7.15. So the mode for this example is $7.15. Another example of mode, when all values occur the same number of times, there is no mode. You must have at least one value that occurs more often than the others. Also, when you are talking about mode, if we have more than one number occurring the most often, we could have more than one mode. For example, in here we have, there's 59, 1, 2, 3 number 59s, and we have 1, 2, 3 62s, and we have 1, 2, 3 47s. So there are multiple modes, and the modes for this example are 47, 59, and 62. Each of those values occurs 3 times, which is more than 35 and 38, so we have 3 modes. Frequency distribution. Sometimes we organize our set of data into a frequency distribution table. We do this when we have a large set of values. When you look at this large set of values, it's too hard to see where things are. So we do what we call a class interval. We group our numbers into classes. And when we look at our set of values, we see that our smallest number appears to be 63. So our interval should start with 60. And our largest value appears to be 97. So our class interval should end with 97. And we usually will make them 3 to 4 or 5 groups. So, for example, our 60 to 64 includes 5 values, and 65 to 69 includes 5 values, and all the way down the list. We group them off in sets of 5. Then we find our midpoint. Our midpoint is our next column. The midpoint is the middle value between each of those class intervals. So the midpoint for 60 to 64 is 62. The midpoint from 65 to 69 is 67. And from 70 to 74 is 72. And from 75 to 79 is 77. 80 to 84, the midpoint is 82. 85 to 89, the midpoint is 87. 90 to 94, the midpoint is 92. And finally, 95 to 99, the midpoint is 97. Then we tally how many of these numbers fall into our class interval. For example, we have here a 76. The 76 would fall in the 75 to 79 range, so we put a tally mark. Then we have a 91 that falls in the 90 to 94 range, and we put a tally mark. And we keep doing that till we get through all of our values. And we will end up with 1 in the first class interval, 1 in the second, 2 in the third, 6, 4, 5, 6 in the 75 to 79 range, 3 in the next one, 5 in the next one, 5 in the next one, and 2 in the last one. Okay. Now our frequency are those digits. There's one tally. We use a different color here. There's one tally. Here's one tally. Here's 2. Here's 6. Here's 3, 5, 5, and 2. From this class or frequency distribution, we can answer questions such as how many students scored 70 or above? Well, we find the 70 and above range and we add those all together. And that would give us 23 students scored 70 and above. Mean of grouped data. Now this is different than just finding the mean. For the mean, you add up all your values and then divide by how many there are. Grouped mean, we add up all the values of our midpoint, which is x, times our frequency, which is f. And we divide by the total number of frequencies. So in this example, we have our class intervals 0 to 4, 5 to 9, 10 to 14, 15 to 19, and their midpoint is 2, 7, 12, 17. And our frequencies are 3, 7, 4, 2. And we total those up, and that gives us 16. Now, when we multiply to find our product, x times f, we multiply 2 times 3, which is 6. Then 7 times 7 is 49. 12 times 4 is 48. 17 times 2 is 34. And then we add those all up, and that gives us 137. Using our formula, we now take our grouped mean, I'm going to abbreviate that GM, is the sum of all the products, 137, divided by the sum of all the frequencies, 16. So our group mean is 8.56, and we can round that off usually to 9, the next whole number up.